Continuing our lesson on inequalities, sometimes we have two inequalities at the same time, and we have them in what's called a compound inequality. That means you'll have some inequalities, like say x greater than 2 and x maybe less than 10, but there's a word in between them, okay? And so the word in between them that would sit right in here could be either the word and, or it could be the word or. We want to talk about what do you do with both of these types of words. So I want you to think about this with me for a second. If we think about a classroom, and we think about inside the classroom, we have boys and girls, and they all have brown or blonde hair. If I ask for all of the boys and brown hair to stay standing, so boys and brown hair stay standing, I'm going to have a couple of boys who have brown hair. If you're a boy and you have brown hair, so maybe 3 or 4. But if I say, stand up if you're a boy or you have brown hair, now I'm going to have the boys with brown hair, sure, but I said boys or brown hair, so I could have blonde boys standing up and I could have brown hair girls standing up. So now I'm going to have a lot more people in here. So these two words actually stand for two different scenarios. This guy is a very exclusive type of person. And so when he chooses his friends, he's kind of snobbish. So that's him sticking his nose up in the air. Small groups. Versus this fellow over here, when he creates parties, he's excited, and he's just glad to have everyone in the group, and he has big groups. So whenever you see the word or, think about, I could be a boy with brown hair, or I could be a girl with brown hair, or I could be a boy with blonde hair. It doesn't matter. As long as I'm a boy or I have brown hair, I'm included. But when you think about and, you want to be very specific. You must be a boy, and you must have brown hair. Very exclusive fellow over here. Okay? That's going to come in for us with our graphing and our algebra today. So, for example, you might see something like x greater than 2 and x less than 10. Or you might see x greater than 2 or x less than 10. When we graph them, they look very different. Let's do a little thought bubble over here. So this will be our final answer, but before we get there, we're going to do a little thinking. So here's the 2, and here's the 10. Now, we're going to go ahead and we're going to do blues whenever we graph these sides, and we're going to go ahead and do yellows whenever we graph these sides. So, graph this the way you normally would. We start at 2, and it's got to be an open circle because, whoa, sorry, that doesn't look like an open circle, does it? Whoops. All right. Can you pretend with me that that's an open circle? And then we're going to shade all the way this way for yellow. And then for the blue, also an open circle. Let's see if I can make this open this time. There we go. Open circle coming all the way through in here. Because it's or, we don't care if you're a boy with blonde hair or a girl with brown hair as long as you have one or the other. So we are willing to take anything in here. Sure, we'll take yellow or we'll take blue or we'll take the middle. Doesn't matter. So our final answer for this type of graph would be something like this. Everyone gets to be included, whether you were just yellows, whether you did happen to have both, or whether you were just blues. Everyone's included on the graph. So our interval notation for something like this, remember, goes from negative infinity all the way up to infinity, or we said that's all reals. Now, over on the other side of things, if we do a thought bubble before our final answer, and we put in 2 and we put in 10, go ahead and we're going to use yellow color here. It's the open circle. There we go. Shade it all the way over. And then 10, shade it all the way down. And now we want to think about what fits into both categories at the same time. So you must have both. Well, that's only our middle section here, what turned green. So here's 2, and here's 10. We'll shade in between the two. I can't include the outside because that's only blue, and I can't include this side because it's only yellow, so only the middle gets to be shaded. And then for these here, do we need open or closed circles? Well, do you see how this one is open with yellow? And see how the blue passes through right in here? There's blue right there, but there's no yellow. So that doesn't have both, so I can't include it. So this needs to be an open circle as well. You see how this is just yellow right there? There's no blue. So that's also an open circle. So my interval notation will be 2, 10. So again, ands, very small groups of friends. Ors, lots of friends. We like lots and lots and lots and lots of people. We're going to look at a couple examples together. So scroll down your notes with me. Graph the solutions of the following compound inequalities. In order to graph it, we have to solve these first. So we have to do some algebra, then we can do the graph, and we are going to put interval notation over here at the very end. We're going to keep practicing that. So let's solve these. Let's take our, let's see, we have a 2x and a 3x. Let's move that 2x over. So subtract 2x from both sides. So we get -1 less than or equal to 1x, or -1 is less than or equal to x. This one, again, let's subtract the x over. So we get 0 greater than 3x minus 9. Move the 9 over. 9 is greater than 3x. Divide both sides by 3. So 3 is greater than x. I'm just going to copy this down so it's all on the same line. Nothing changed. And keep this word all the way down. So this is our algebraic answer. X is greater than or equal to -1, and x is less than 3 at the same time. So do our thought bubble line up top here. And with our thought bubble, we need a -1 and we need a 3. Let's go ahead and let's choose our shading colors here. So for the -1, I'm greater than or equal to. So I can do a closed dot, and I'm all the way up. And then for 3, open circle, and all the way down. And then I need to think about on my graph, what am I going to get to graph in here? And, so it has to be both at the same time. I see greens in here between the -1 and the 3. So I'm going to shade between those. This only has yellow, so it's going to be open circle. But this one here has yellow and blue together, so this one's going to be a closed circle. So this is my final answer graph. That is part of my work. This is the final answer. Then this is my final algebraic answer, and my final interval notation will be bracket -1, 3, parentheses. All right, next page, page 17. Okay. Sometimes you'll see inequalities like this, where you actually have what we call double-sided. There's this outside, and there's this outside, and some stuff in the middle. Your job is to isolate the x. That's what you're focusing on right here. Okay? So in order to do that, don't worry about what's on the outsides. Just make sure that your x is in the middle and we get it alone. So we're going to move that +1 over, but that means we have to do it to all 3 sides. So pay attention. That's an important thing. This side, the middle, and the other side. So we get 15 greater than 3x greater than or equal to -9. We have to get the x by itself, so we'll divide by 3, but again, to all 3 sides. I'm going to move my work up top. 15 divided by 3 is 5, is greater than x is greater than or equal to -3. That's your algebraic answer. What does this mean? This means that x has to be greater than or equal to -3, while at the same time, x is also less than 5. So on our graph, here's -3. 2, 1, 0, 1, 2, 3, 4. Here's 5. Closed circle at the 3. Open circle at 5. x must be between them. So these ones are actually really nice to graph. You don't have to do the thought bubbles if you have a double-sided one. It shows you that x must be between them. It can't go beyond the 5, and it can't go beyond the negative 3. So it stops right in between them. Interval notation for this one, bracket negative 3, comma 5, parentheses. Here's another one for us to try. Same idea. We're trying to isolate this x right in here. So we will focus on getting that 4 out of the way and getting that 2 out of the way. When we add 4, we do it to all 3 sides. And then when we divide by 2, we do it to all 3 sides again. So we get negative 1 less than x less than or equal to 8. Again, you don't have to do a thought bubble if it's double-sided like this. So we get negative 1 and 8, open circle and close circle. And interval notation. Okay, so that's how you do the double-sided ones. Let's go back to the ones that have words in them, like these. So if we look at another OR, we have to solve them separately. So let's start by moving this 9. So we get 3x less than negative 12. Divide both sides by 3. So we have x is less than negative 4. Or, remember that's part of your answer, so that has to be there. Negative 1, negative 1. Negative 2x is less than 4. We're dividing by a negative this time, so we get x and we get negative 2. But remember, the sign has to switch because we divided by a negative. So that's our algebraic answer here. Now we do need a thought bubble for this one since we're graphing 2 different things with that word. So here's negative 4 and negative 2. We'll grab our colors. Okay. X is greater than negative 2, so, and it's an open circle, so open circle all the way up. And x is less than negative 4, it's also an open circle and going down. And it's an OR. Remember, this guy's the happy guy. Big parties. He doesn't care. If you're yellow or if you're blue, he's fine. So our final answer, we'll actually go ahead and we'll put both of these on the same graph. There's nowhere that they overlap, but we don't care. As long as you're yellow or blue, you're good to go. Now, interval notation for this. Notice how you have this piece here. Interval notation would have been negative infinity, comma, negative 4, and then a parentheses. Interval notation for this piece would be parentheses 2, positive infinity. We have to add one little thing. Whenever you have more than one interval, so here we have 2 intervals, you have to put a special symbol like this between them. That special symbol is called the union symbol. It just means we mean this number as well as these numbers together. So that's part of our answer as well. So this is our final answer graph, and this is our final answer interval notation. Now I actually want you guys to think about this one with me here for a second. So we're going to skip down to the bottom of your notes just a little bit, and we're actually going to cross off F. So we're not going to do F at all. So just go ahead and cross him off. Don't worry about him. What I want you to think about is draw an arrow down here for D. And we're going to think about this together. Let's suppose that we have the same thing here. We have x less than negative 4 or x greater than negative 2. And on this side, it's x less than negative 4, same work, and x greater than negative 2. So same numbers, but just different words. Think about your thought bubbles for these. We said these are open circles at 4, and they go all the way down. Open circles at 4, all the way down. And for 2, negative 2, open circles all the way up. Open circles all the way up. Now, For the final answer, down here for ors, we already did this one. We know that we said, hey, he doesn't care. He's a happy guy. He'll take you if you're yellow or blue. So we're going to shade these outside parts for an or. However, for the and over here, he's a picky fellow. Remember, you have to be both yellow and blue. Nowhere on this graph do yellow and blue ever overlap. So for this one, because he's an and he's being picky, he doesn't get any answer. There's no place. The answer for this is no solution. There's nowhere where they overlap. So this is why it makes a big difference what your word is. It's the same numbers, it's the same math, it's even the same thought bubbles. But the or says, yeah, sure, include everyone. The and says, nope, no one overlaps, I'm not inviting anyone. So watch out for that when you're doing your homework tonight.